Friends, in this video we will see the moment of inertia. So how to define the moment of inertia? When a body is in rotational motion and refers to its resistance to a change in rotation speed about a given axis when subjected to a turning force. There are three types of moment of inertia: mass moment of inertia, area moment of inertia, and polar moment of inertia. So out of these three moment of inertia, we'll see the area moment of inertia. So this concept will see consider a one plane lamina, irregular shape plane lamina, and draw x axis and y axis. So in that axis, take the small elemental area, having the area is dA, and x distance from the y axis and y distance from the x axis. So first moment of inertia is what? The measure of the distribution of an area relative to an axis. And mathematically how to define this is Ix is equals to integration y dA. So we can see here the distribution of an area relative to an axis, about the x-axis and about the y-axis. So Ix is about the x-axis is integration y dA, and Iy or integration moment of inertia about the y-axis is integration x dA. Then similarly for the second moment of inertia. So second moment of inertia is what? Measure of the resistance to torsion. So Ix moment of inertia about the x-axis is integration y dA, y square dA, and moment of inertia about the y-axis is integration x square dA. So this is the concept of first moment of inertia and second moment of inertia. Now some standard shapes moment of inertia there. Area moment of inertia. So we have the directly equations for the rectangle shape, rectangle, triangle, and circle. So how will we get these formulas? So this here, if we see the rectangle, Ix or moment of inertia about the x-axis is bh cube by 12. So how will we get this formula? So we will see the first example, that is a rectangle. Consider a one rectangle. I draw x-axis which is passing through the midpoint of the height of rectangle, then y-axis which is passing through the width of center midpoint of width. Then consider a small elemental strip having distance y from the x-axis and its height is dy. Rectangle width b and rectangle height is h. So above the x-axis there is h by 2 and below the x-axis is h by 2. Then we know the formula of second moment of inertia. Moment of inertia about the x-axis. We know the formula, that is integration y square dA. So area, how to calculate area? In this case, that is width b into height dy. So put this value in this equation. So Ixx is equals to integration y square, area is b into dy. So just again integrate with the limit is minus h by 2 below the x-axis and above the x-axis. It is a rotation. So this is a integration minus h by 2 to the h by 2 y square b dy. So take the integration of this. B is constant, width constant, take outside of integration, and y square integration is y cube divided by 3, and limit is minus h by 2 to h by 2. Put the upper limit minus lower limit. So we'll get the b is b into bracket h cube by 24 plus h cube by 24. So again simplify it. So moment of inertia about the x-axis is bh cube by 12. So in this way we can calculate the area moment of inertia of any standard shapes. Then parallel axis theorem. So what is the parallel axis theorem? Again we consider the rectangle. So with this with the help of this rectangle we'll clear the here the parallel axis theorem. Consider a rectangle, x axis which is passing through the midpoint of the height of the rectangle, then y axis which is passing through the midpoint of width. Now here parallel axis theorem, when we use the parallel axis theorem, when other than the centroidal axis we want to calculate the moment of inertia, then we utilize the parallel axis theorem. Here in rectangle case, the centroidal axis is where the x axis and centroidal y axis is there. So other than this axis we want to find the moment of inertia about the AB. You can see here at the lower edge of this rectangle. Then how to find the moment of inertia about this AB? For that, consider a small element which is having y distance from the x axis and its height is dy, and rectangle width is b, height is h by 2 above the x axis and h by 2 below the x axis, and from the AB the distance to the centroidal axis is yc. Then what is the parallel axis theorem? Moment of inertia about any axis in the plane of an area is equal to the sum of the moment of inertia about a parallel centroidal axis and the product of area and the square of the distance between the two parallel axes. It is called as parallel axis theorem. In short, we define here the moment of inertia about the AB other than the centroidal axis. The moment of inertia IAB, we define here the moment of inertia IAB is equals to moment of inertia about the centroidal axis IXX plus area, total area of rectangle into distance square. Distance square means what? Distance from the centroidal axis. Distance from the centroidal axis square. So it is a statement, in the statement clearly mentioned there, the area is equal to the moment of inertia about any axis in the plane of area is equal to the sum of moment of inertia about the parallel centroidal axis and the product of area and the square of the distance between the two parallel axes. So this is the parallel axis theorem. Now perpendicular axis theorem. The moment of inertia of an area about an axis perpendicular to its plane. In bracket there is a polar moment of inertia at any point is equal to the sum of moments of inertia about any two mutually perpendicular axes through the same point O and lying in the plane of the area. So we will see here consider for that there is a 2D coordinate system, x and y axis. Consider a irregular plane lamina. Consider one small elemental area having the area is dA and distance is x from the y axis and from the x axis y, and from the origin O to the distance of small elemental is r. Then its moment of inertia about the z axis is what? Which is perpendicular to this plane. IZZ or moment of inertia about the z axis. Okay, so IZZ is equals to integration RdA is equals to integration x square plus y square dA. So just simplify it, multiply separately dA with x square and y square and take the integration. So IZZ is equals to integration x square dA plus integration y square dA. So integration x square dA and y square dA, we know the value of this is the second moment of inertia. So IZZ is equals to I yy plus ixx. So again simplify it. So izz is equals to, or moment of inertia about the z-axis which is perpendicular to the this plane, is equals to moment of inertia about the x-axis axis plus moment of inertia about the y-y axis. So this is the perpendicular axis theorem.